All right, for this next one, solving compound inequalities is really the same thing as solving inequalities, except we have twice as much work to do for each one. So like this one, I have three sides to this inequality. I have that piece on the left, the piece on the right, and the piece in the middle. So I look where x is. Right now I have a 2x minus 7. If I had that in any other situation, I would add 7 to get rid of the 7. I'm just going to do that to each of the ends as well. Okay, so I do it in three different places. So this gives me a 4 less than or equal to the 2x less than a 16. And now, looking at that middle section again, if I wanted to take x by itself, I would divide by 2. I do the same thing to each of the ends as well. All right. So I'm just doing this to all three pieces. I'm essentially solving two inequalities at the same time. So we got 2 less than or equal to x less than an 8. And that's it. Okay. Next one, same kind of thing. I'm going to solve each of these just individually. So I solve this first inequality. I subtract the 5 from each side. That gives me the 3x is greater than or equal to a 14. And then I divide each side by the 3. So I've got x is greater than or equal to the 14 over 3. And then I solve the next one. I add the 6 to each side. That gives me a negative 2x is greater than a 10. And then I divide each side by the negative 2. Because it's an inequality, since I'm dividing by a negative, I have to flip the inequality sign, so that becomes a less than symbol with the negative 5. And then I just keep that word or in between these, and I'm done. That's it. Okay. Next one, same kind of thing. I see all these fractions, so I say, okay, what's the common denominator? The common denominator between all the fractions is a 6. So I'm going to multiply everything, all three sides, by 6. Okay? Whatever I do to one side, I do to the other side, and I do to the other side. So I know multiply everything by 6 here. Over here, that gives me a negative 9. Here, that gives me, let's see, a 12, an 8x minus 18. And then over here, it looks like I get a 5. All right, and now I'm in the same boat that I was in number 46. I just start undoing these things to all three sides, so I add the 18. Whatever I do to one side, I do to each end as well. So that gives me a 9 less than 8x less than or equal to a 23. And now I divide each side, or all three sides, rather, by the 8. I'm going to leave each of these as improper fractions. So this looks like a 9/8 is less than x less than or equal to a 23/8. And that's it. I'm done. Okay. The next one, again, remember when we're looking at these guys, something like this, anytime we have an absolute value, we're going to split this into two different things. Because remember, the absolute value could be what's over there. So in other words, the 2x plus 5 could equal a 13, and it'll give me this answer. Or the 2x plus 5 could equal a negative 13, and it would still give me this answer. Okay? So anytime I have an inequality, an absolute value, I have to split it into two things. So this is an absolute value equation. I split it into two equations. Okay? And so now I just solve each of these. This one, I subtract the 5 from each side. I'm going to do the same thing over here, subtract the 5 from each side. It's the same steps for each equation. So I get the 2x equals an 8. Over here I get a 2x equals a negative 18. And now I divide each side by the 2. Again, I would solve this one the same way by dividing each side by 2. And so I get x equals a 4 and x equals a negative 9. Okay? And the last thing I should do is plug those back in and check them to make sure that they work. These ones do when I plug it back in. Just do a quick mental check. All right? The next one, I have to get the absolute value by itself first, so I'm going to subtract the 7 from each side. And so I get the absolute value of 4x minus 3 equals a negative 3. From here is where I would normally split this up and do the 4x minus 3 equals 3, and then the 4x minus 3 equals the negative 3. But the thing I should recognize is that the absolute value here can't equal a negative, and what the equation said is literally absolute value equals a negative 3, which doesn't make any sense. This is a no solution. Okay? And as soon as I see the absolute value equals a negative, I can say that. If you miss it here and split this up and solve this and get the two answers, well, just plug them back in. You'll find out that neither answer works, so they're extraneous solutions. Okay? This one, same kind of thing. I got to get that absolute value by itself, so I'm going to subtract the 5 from each side. That gives me a 1/3 times the absolute value of x minus 2 equals a 2. And now I'm going to get rid of that 1/3 by multiplying by 3. Whatever I do to one side, I have to do to the other side. So now I've got the absolute value of x minus 2 equals a 6. Now I can split this thing up. X minus 2 equals a 6, or x minus 2 equals a negative 6. I split it into two things. And now I solve each of these. For this one, I add the 2 to each side. For this one, to solve it, I also add a 2 to each side. And so the two answers I come up with looks like an x equals 8 and an x equals negative 4. And you can plug those back in, and when you do, you should find out that they work. Okay? The next one, it's an inequality this time, so I'm going to split it into two inequalities, okay? So again, very similar to the equation. So I do x plus 4 is less than the 12, which is pretty much what's written there if I ignore the absolute value. But then when I do the negative version, I have to flip the inequality sign, so I say greater than a negative 12. Okay? So what's inside there could be less than the 12 or greater than the negative 12. And now I solve each of these. Once again, solving each of these, here I'm going to subtract the 4. Here I'm going to do the same thing. So I get x is less than an 8. Over here I get x is greater than a negative 16. But then the last thing I have to do, I have to determine if this is an and inequality and an or inequality. If I have two inequalities, it's either an and or an or. All right, so this one, the easiest thing to do is just remember, if the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. Remember, we did that by saying absolute value is less than, absolute value is greater. So this one is less than, so it's an and. So you can put the word and in between there. The more appropriate way to write it then is negative 16 less than x less than 8. I can write it all as one string. Okay? You can't do that with the or, so just keep that in mind. This one, once again, I got to get the absolute value by itself first, so I'm going to add the 5 to each side. And so I get the absolute value of 4b minus 2 is less than or equal to the 14. And now I'm going to split it up. Again, I do the positive version and the negative version. When I do the positive version, I just leave this thing the way it is. When I do the negative version, I have to flip the inequality sign. Okay? And now I'm going to solve each of these. I add the 2 to each side. I'm going to solve this one the same way by adding the 2 to each side. And I'm just solving these simultaneously to kind of make this go a little bit quicker. Here I get a 16. Here I get 4b is greater than a negative 12. And now I divide each side by the 4. Over here as well as over here. And so the two values I come up with are b is less than or equal to 4. But then I also have a b is greater than or equal to a negative 3. Because the absolute value, again, I go to this step right here when the absolute value was by itself. The absolute value is less than, so it's an and inequality. So I'm going to rewrite it as negative 3 less than or equal to b less than or equal to 4. Okay, I'm going to write it all as one string. Okay. Next one, again, I got to get that absolute value by itself, so I'm going to divide each side by the negative 2. When I do that, I have to flip the inequality sign, so it becomes the absolute value of 2w plus 4 is greater than a 4, and now I can split it up. So I do the 2w plus 4 is greater than 4. I then do the 2w plus 4 is less than a negative 4, and I solve each of these. Here I subtract the 4 from each side. That's the first step that I'll take over here as well. That gives me a 0. Over here, 2w is less than a negative 8. And now I divide each side by the 2. Same thing over here. So the two inequalities I get are a w is greater than 0. And then I also get a w is less than a negative 4. Because the absolute value, again, go to the step where the absolute value is by itself. This step right here says the absolute value is greater than, so greater. I slap an or symbol in between. And I can't write or as one string, so I just leave it as separate inequalities with the word or in between, and I'm done. Okay? The next one, it says you have two boxes of colored pencils, or sorry, colored pens. The first box contains a red pen, a blue pen, and a green pen. The second box contains a yellow pen, a red pen, and a black pen. And what is the set that represents all pens? And so when you think about this, you know, if you think about this in terms of a Venn diagram, we'll start off that way. So this is the first box and the second box. So the first box, I should have, let's see, a red, a blue, and a green. And so as I'm going to write those down, the red is actually in both boxes, so I'm going to put that in the overlap. And then the blue, there's only blue over here. And then the green, there's only green over here. And then the other box has the yellow pen, a red pen, which is already included in the overlap, and a black pen. And so when you think about the set that represents all of them, I wouldn't write the red twice. I would just say the set contains blue, green, red, which I only write once, yellow, and black. Okay? And really this is like the union of the two sets, or sorry, the union of the two sets, because we're including everything from each. Okay? I'm going to put braces around this, so there's my set for everything. Okay? If it asks for the intersection, which is the only what they have in common, then it would be just the red pen. Okay? And we could express that in terms of union symbols and that kind of stuff as well. But if we look at the next one, it says 360 consumers polled. Some purchase ice cream, some purchase frozen yogurt, and some purchase both. If 260 people polled purchase ice cream and 250 purchase both ice cream and frozen yogurt, how many people purchase just frozen yogurt? And so again, I'm sorry, it doesn't say just frozen yogurt, it says frozen yogurt in general, so this will include the overlap as well. And so the way to do this is to set up a Venn diagram. And here's the thing, the first thing we start with is the 250 that are in on both of these. So we've got our ice cream people and our frozen yogurt people over here, okay? And so when we look at this, if there's 250 people in the overlap, notice it says that there's only 360 people total. The other thing it tells me that is 260 people purchase ice cream. Now here's the thing, those 250 that are in the overlap, they purchase ice cream, so that's part of that 260, which means in terms of only ice cream, there's only 10 left over here, okay? And so when we look at this, there are 360 people total. There are 260 accounted for right now, which means there's 100 left that must be over here in terms of only purchasing frozen yogurt, okay? And so when you look at how many people we have total, we can see the 360. We can see that 10 only purchase ice cream, 100 only purchase frozen yogurt, but the majority of people, 250, purchase ice cream and frozen yogurt. The question, though, asks for who purchases frozen yogurt, which is everybody who's in this second circle over here. Okay? Not just the 100, but also the 250. So there's a total of 350 people that purchase frozen yogurt. Okay? If it asks for people who only purchase frozen yogurt, then it would be the 100. Okay? So you got to be really careful about the wording there. All right? This one says write a function and determine if the graph is continuous or discrete. And so this first one, it says a movie store sells DVDs for $11 each. What is the cost C of N DVDs? So the cost would equal $11 per DVD, which is N. And when we look at this thing, this is my equation. And continuous versus discrete is basically asking, like, when you think about the graph of this thing, would I have individual points, or would I have values in between? Like, could I buy half a DVD? And the answer here is no, I can't buy half a DVD, which means my graph would kind of go in little increments like this. I would have a point here and a point here, but I wouldn't have values in between. So this one is discrete. The next one, when we look at this, a produce stand sells roasted peanuts for $1.90 per pound. What is the cost C of P pounds of peanuts? And so just like setting up the last equation, the cost equals $1.90 per pound of peanuts, so P. And the question is, do I have to buy individual pounds of peanuts, or could I buy a half a pound of peanuts? And the answer is typically, yeah, I can buy half a pound of peanuts. Essentially, you scoop these things out, so I could have half a pound of peanuts. So we're going to say this is continuous. I not only have like the exact values of pounds, but I also have values that are in between. Okay? And my T looks like a little bit like an F there. I don't like it. There we go. Okay. Next one, it says describe the pattern and find the next two terms. So if we look at this one, looks like we're going down by 2 each time, so I'm subtracting 2. So that means the next value in the pattern would be a 16. The one after that would be a 14. Okay? And that's it. So I've described it, and then I've found the next two terms. The next one, if I describe the pattern, what's happening here is it looks like I'm multiplying by 2 each time. And if I continue to do that, I would get a 32 followed by a 64. Okay, so the description is that I'm multiplying by 2 each time. The next two terms are the 32 and the 64. Okay. And then the next question says, which of the functions above is arithmetic, and identify the common difference. Remember, arithmetic means we're adding the same thing each time. So we could consider number 59 an arithmetic sequence because the thing we're adding each time, the common difference, is a -2. So it doesn't matter that we're subtracting. I'm adding a -2, so it's arithmetic. Okay? This one, it says the table below shows the number of miles driven over time, and we want to find the rate of change. So again, the rate of change is just how the x is changing over how the y is changing. So like when I look here, I went up by 2, and it looks like it's going up by 2 each time. Over here, it looks like this is going up by 102 each time. So then the rate of change, I would take the change in y over the change in x. And so when you look at each of these, I get 102 over a 2 for each of them. You know, here 102 over 2. And then the next one will be 102 over 2. And so I know this is linear because the rate of change is constant. It's 102 over 2, which is 51. Okay? So the rate of change is 51, and that's miles per hour because I'm doing the distance divided by the hours, the miles divided by hours. Okay? The next one asks me to find the slope of each of these. The first one, again, I just have to kind of identify 2 points that are definitely on here. I've got a point here, it looks like, and then I've got another point right here. I've got another point right here. So if I start at any one of those points and count up, it looks like I have to go up 1, and then I have to count over 4 units. So again, slope is rise over run. So when I calculate my slope, it's rise, which was 1, over run, which is 4. So the slope is 1/4. Okay. The next one, I don't know if you can see my line here. It's a little tough to see. It's right here. It's this vertical line. And remember, vertical and horizontal lines are special. A horizontal line would have a slope of 0. A vertical line, the slope is undefined. Okay. It's so steep we can't measure it anymore. So undefined. All right. Again, a horizontal line would be 0. A vertical line is undefined. Okay. The next three ask me to find the slope of the line, then the slope of the parallel line, then the slope of the perpendicular line. Okay? So to find the slope of the line, I'm just going to do my slope formula. I do y2 minus y1 over x2 minus x1. And make sure you're consistent in terms of the order there. That gives me a 3 over 6, which is 1/2. All right? So the slope of my line is a 1/2. That means the parallel line would also have a slope of 1/2 because parallel lines have the same slope. The slope of the perpendicular line would be the opposite reciprocal, which is a -2 over 1, which is a -2. Okay? So there's the slope, parallel line, and then the perpendicular line. Okay? Same thing with the next one. I'm going to do my y value, -1 minus 7 over 0 minus a -2. That gives me, again, that's adding the opposite. That's a -8. Down here, that's adding the opposite. That's a +2, so I get a -4. So that's the slope of this thing. So the parallel line would also have a slope of -4 because parallel lines have the same slope. The slope of the perpendicular line would be the opposite reciprocal, so it's going to be a positive 1/4. I change the sign and flip it. Okay? The next one, again, finding that slope, I do the 14 minus the 5 over, down here I do the 3 minus the 3. So what I end up with is an 11 over 0, but I can't divide by 0, so that means this is undefined. So that's the slope of my line. The parallel line would have the same slope, so it would also be undefined. And then the perpendicular line would be the opposite reciprocal. If you're going to do opposite reciprocal, you have to go back to where we had numbers, the 11 over 0. So I would do 0 over negative 11, which is 0. You can also think of it this way. An undefined line is vertical. Therefore, the perpendicular line must be horizontal. It has a slope of 0. Okay? The next one, it says, does the equation represent direct variation? And so all I have to do here is solve for y. Remember, direct variation would be in the form y equals kx. It's essentially a slope-intercept type of equation that goes through 0, 0. It's a line that goes through 0, 0. So it's a y equals mx plus b where b is 0. So we call it y equals kx. So all I'm going to do is go ahead and solve for y. So I'm going to subtract the 2x from each side. I'm just going to see if it falls into this format, to see if it has a y-intercept of 0. And then I divide each side by the negative 4. So I find out y equals, looks like a 1/2 x. And so the answer is yes, this is direct variation. Because when I look at this thing, it's in the form y equals kx. The constant of variation is 1/2. It's y equals mx plus b with a y-intercept of 0. Okay? The next one says y varies directly with x, so it's telling me that this is direct variation, so I know I'm going to follow the pattern y equals kx. And then it gives me an x and a y value. It says that if I plug a 10 in for y, my x value should be a negative 3. And so now what I can do is I can solve for k. I can find the constant of variation. So I find out that k equals a negative 10/3. And so now the equation I could write for this particular guy is y equals a negative 10/3 x. And now if I want to find other values, all right, all I have to do is plug the values into my equation. And so this one asks me to plug a negative 1 in for x. And when I do that, I find out that y equals a 10/3. And that's it. Okay, so it asked me to write the equation. That was this guy. And then it asked me to find that value, which is the y value that I've written down here. And that's it. This one, it says the grade a student makes on a test varies directly with the amount of time the student spends studying. Suppose a student spends 5.5 hours studying and makes a grade of 76% on the test. What is an equation that relates the grade earned on a test, G, with the amount of time spent studying, T? And so we're going to kind of do the same thing. We're going to do y equals kx. The big difference this time is instead of y, they told me to use a G for grade. Instead of x, they told me to use a T for time. All right? But then they still do the same thing where they give me two of these values. They give me a grade of 76 and tell me that it matches up with a 5.5 in terms of the time. Okay? And so all I'm going to do is solve for the k value. So here I'm going to find out that k equals, let's see, 76 divided by the 5.5. Looks like a 13.81. I'm just going to leave this thing in terms of a fraction. Let me think about this and reduce that. Looks like I'd have to multiply the numerator and denominator by 2, so I'm just going to leave it as 152 over 11, okay? Rather than round it off as a decimal. So that's my k values, which means my equation is my grade would equal 152 over 11 times the amount of time that I spend studying, okay? And so then the question is, what is the equation that relates the grade? It's this guy right here. All I have to do is just plug in my k value, and I'm done, okay? The next one, it says the table shows the height of an elevator above ground level after a certain amount of time. Write an equation that represents the data where y is the height and x is the number of seconds. Okay, and so once again, we kind of look at this and say, all right, if it's a rate of change that's constant, this goes up by 10 each. Well, it goes up by 10 the first time, and then it goes up by 20, and then it goes up by 20 again. All right. Over here, I have to kind of look at this. These values and see how much this thing is changing. It went down the first time. It looks like it went down by 18, so I'm going to write a negative 18. Then it went down by 148. which is a negative 36. It went down to 148, and then from the 148 it went down to the 112, which also I believe is negative 36. Okay, and so when we look at this, again, changed in y over changed in x, it was negative 18 over 10, then it was negative 36 over 20, and then it was another negative 36 over 20. The thing I should realize is that this does remain constant. That's a negative 9/5. This is a negative 9/5, and this is also a negative 9/5. So that's my rate of change. That's essentially my slope that I'm going with here. So the slope is a negative 9/5. And then the question is, looking at this thing in terms of time, we got to work our way back to a time of 0. There's a couple ways to do that. I'm just going to go ahead and write y equals mx plus b here and say, okay, the slope is a negative 9 over 5. One of the ordered pairs that I'm given was the 10, 202. And now I can just go ahead and solve this thing for b. So I've got 202 equals. Right here I can cross-reduce a little bit. When I multiply these fractions, that's a 1 and a 2. And so I get a negative 18, it looks like. And I'm going to add that 18 to each side. You can also do point slope form and plug this into point slope form and then rearrange it. And that will work as well. Or you can kind of look at this thing and kind of work your way backward and say, oh, I've got to go up 18 more feet to get back to a time of 0, kind of using your slope and what we've seen in terms of the pattern in the table. Okay, but when I do this, this gives me a 220. So my equation would be y equals negative 9/5 x plus 220. And so it's essentially saying I started at a height of 220, and I'm going down 9.5 feet every second. Okay.